Okay, so I have this question, a Euclidean geometry question. In the diagram below, DF is a diameter of the circle with center O. Chord EG intersects DF at H such that DF is perpendicular to EG. Chords EF and GF are drawn. Angle EGF is equal to 55 degrees. Okay, they say determine, giving reasons, the size of D. Okay, so let's see, what can we relate D to? Okay, so I see that I have a chord EF, right? If I extend this chord EF to the other side of the circumference, if I can extend EF to the point D and I can extend it to the point G. So I've now got this bow tie. So whenever I see this bow tie type shape and it lies on the circumference of the circle, I can say that this angle is equal to this angle. And this is called my angles in the same segment. So using the theorem that angles in the same segment are equal, I will say that D is equal to 55 degrees. My reasoning, angles in same segment. Okay, now they ask O2. O2 is a fairly simple one, it's this angle. So I can see that O2 is my angle at the center, and I can see that I have an angle at the circumference. So if it's also the same, if it's subtended by the same chord, so if this chord meets at the center, EF, if I extend it to the center, I'll meet at O2. If I extend EF to the point G, I can see that I have this bow tie now. One where there's one angle at the center and one at the circumference. And I have a theorem that states that the angle at the center is 2 times the angle at circumference. So I know that O2 will be 110 degrees. Reason, angle at center is equal to 2 times angle at circumference. Okay. Now they say, let's just delete this. So let me just delete all this. Now they ask us to find E2. How can we find E2? So if I look at this triangle, EHO, I know that this is also at H2 is 90 degrees because they tell us that the DF is perpendicular to EG, so H3 and H2 has to be 90 degrees. And I know O2. And I have something that says in triangles that the exterior opposite angle, in this case O2, is equal to the interior opposites. So let me just redraw this triangle with the exterior angle. So I have O2, which I know is 110 degrees. I know I have this angle that's 90 degrees. So I know that the exterior angle is equal to the sum of the two interior angles. So therefore I know that O2 must equal H2 plus E2. Now I know that O2 is 110 degrees. I know H2 is 90 degrees. And E2 is what we're trying to find. Therefore, E2, if we work it out, E2 should be 20 degrees. So I know E2 is equal to 20 degrees. And my reasoning is exterior angle of triangle. Okay. And now lastly, they ask us to find E3. So how do we find E3? So if I look at this triangle, EOF, I can see that EO and OF are radii, so they are equal. So I know that these two are equal. So if I know that EO is equal to OF, I know that E3 is equal to F1, right? I know that E3 would be equal to F1 because of angles opposite equal, sides are equal. And I know O2. So I know the sum of a triangle has to be equal to 180 is equal to O2, which is 110 degrees, plus E3 plus F1. I know, let's say that E3 is equal to X, right? And because E3 is equal to F1, I can say F1 is also equal to X. So I'd have 180 is equal to 110 plus X, which give me 2X. Therefore, I have 70 is equal to 2X. Therefore, I know X is equal to 35 degrees. So I know E3 is equal to 35 degrees. And my reasoning would be angles opposite equal sides. I think you do have to have two separate reasonings. But okay.